So I need you guys to write this right here. Most of these words you already know, like I'm pretty sure you know what the index means. Right? The index tells you the type of root. The symbol itself is called a radical sign. This little square root symbol is called a radical. And the expression inside of a radical sign is called the radicand. And then you need to write this little explanation. You can only add or subtract
if it's the same index and the same radical. It can't just be a square root plus a square root. It has to be the same things on the inside as well. Exact same things on the inside. Those are called like radicals. It's very much like algebraic expressions. If I asked you to add 2x and 3x, what would you tell me? 5x, right? Because those are like terms. What about 2y plus 3y? What about 2x plus 3y? You can't add those together, right? Because they're not the same. It's the same with radicals.
Okay. This problem here, for example. 3 square roots of 2 plus 5 square roots of 2. So if you have 3 square roots of 2 and I give you 5 more square roots of 2, how many square roots of 2 do you have?
8. So the answer here is 8
square roots of 2. The radicand doesn't change. It's kind of like adding denominators of a fraction. If you have 1/3 plus 7/3, how many thirds do you have?
8 thirds. The denominator doesn't change. This is like this. 3 square roots of 2 plus 5 square roots of 2 is 8.
Square roots of 2. Easy, huh? Try this one.
So does it have to have both the same index and the just one or the other?
It has to have the same index. So these are both square roots, right? And it has to have the same number underneath. Those are called the radicand. Those both have to match. And if they do, you can add them. The numbers on the front don't have to match. Those are just coefficients. Those can be whatever. So 2y square roots of 3x plus 9y square roots of 3x. First of all, can they even be added? Same index, and they have the same radicand. So what do we get? 11y don't be shy, square root of 3x. Man, math is so easy. Okay, crack your books open. 247. $247. I think that's the right page. Is that a 4.3 page?
Can I go to the bathroom?
Yes. So the very, very top of page 247, there's a problem 1. Got it? Yeah, do the problem 1 got it problem. Just part A. For right now. Seven times the cube root of 5 minus 4 times the square root of 5. That one can't be done? They have the same radicand. They're both 5 underneath, but it's not the same index. This is a cube root, square root. That problem is as simplified as it can be. There's nothing you can do with that one. What a dumb question. going to part B then. Try part B. Same page. Problem 1, got it. No, we just did a problem like this. Well, this one shouldn't take all too long. First of all, is it even possible? Can this be done? It's a square root and a square root, and they both have the same radical, and it's xy and xy. Yeah, it can be done. Add the terms on the outside. 3x and 4x makes 7x. 7x times the square root of xy. All right, we're not going to even do part C. These are way too easy. Let's go on. New example. Square root of 12 minus the square root of 75. Square root of 12 minus the square root of 75. Yes, no? Thumbs up or thumbs down? What do you think? Square root of 12 minus the square root of 75. Well, just by looking at them, it doesn't look like, I mean, that's the square root of 12, square root of 75. They don't match. It's the same index, but these terms underneath are supposed to be exactly the same. But Kyle, what were you saying? Yeah. Write this down. Simplify first, then combine. Simplify the square root of 12, and then simplify the square root of 75, and maybe, just maybe, we'll be able to do something with it. Well, let's see. The square root of 12. Come on, you guys know this. What is 12? 4 times 3. All right. 75 is 25 times 3. I see where they're going with this. All right, keep going. What happens here? Take out the 4 and it becomes a 2. So that's 2 square roots of 3. And what about the 25? Becomes a 5 square root. Oh, nice. This can be done. Oh, ye of little faith. 2 square roots of 3 minus 5 square roots of 3 is negative 3 square roots. Again, I'm going to make the same suggestion I made during the quiz. If it's just numbers and no variables, you always, always, always ought to verify your results. Like this. Square root of 12.
Do you actually value on that one?
No, if there's no variables, no. Square root of 12 minus the square root of 75 is negative 5.1. Or negative 5.2. What did we say the answer was? Negative 3 root 3? Well, let's just see about that. Ooh, I'm kind of nervous. What if I made a mistake? Whew. No, we're good. Okay. Try this one then. On your own. Page 249.
There's a section near the bottom, I think. 249, where it says, practice. I guess it's at the top of page 249. Top of page 249.
Yeah. Try this one. So, all right.
Oh, yeah.
Check it out. 54 has to be broken up into 27 times 2, not 9 times 6. It's got to be 27 times 2. Why 27? Because 27 is a perfect cube. We're dealing with cube roots, not square roots. It's got to be 27 times 2. And then the 16. Yeah, 16 is a perfect square. That's great, but it's not a perfect cube. 8's a perfect cube.
And 8 goes into 16 twice.
So you split 16 up into 8 times 2. Now, what's the cube root of 27? So you move a 3 out to the front. That's 3 cube roots of 2. Plus, what's the cube root of 8? So that's 2 cube roots of 2. 3 cube roots of 2 plus 2 cube roots of 2 is 5 cube roots of 2. Huh? All right, new topic. Oh, they make a big jump here. Holy smokes. It's still the same section, it's just new topic. I need you to do a couple of review problems though. Just to make sure that you can do these. Because if you can't do these, relatively simple review problems, then you're going to have a lot of issues with what we're about to do. So just do this first one here, x minus 2 times x plus 4. Just see what you can do. It is review. And it should be pretty easy.
Try to simplify that or multiply together. This is a very critical skill. You should, by now, in secondary math 3,
be able to multiply something like that together. Some teachers call it the FOIL method. Even our book calls it the FOIL method. All it is distributing.
what do you call it?
Well, it's an acronym. It stands for first, outside, inside, last is what it stands for. FOIL method. Anyway, it's just distributing. X times x is x squared. X times 4 is plus 4x. Negative 2 times x is negative 2x. Negative 2 times 4, negative 8. Combine your like terms to get x squared plus 2x minus 8. Oh, by the way, what does this word right here even mean? Binomial? 2. This is a binomial, right? X minus 2 is a binomial. X plus 4 is a binomial. So we're multiplying binomial here. We're just going to later on be multiplying binomial radicals. Anyway. Ooh. This also is review. A little more complicated, but it is review.
This is back from Unit 2. You know that unit that we all did so great on? It's the same process, you just distribute. Take a crack at it, would you?
This is something you should be able to do. May not be as easy as the first review problem, but it uses the same idea. You just distribute. What's 3 times 4? Okay. And then 3 times negative 3i? Negative 9i. 2i times 4 is plus 8i. And then 2i times negative 3i. And this is where a lot of you back on this test, this is where a lot of you goofed up. 2i times negative 3i is negative 6i squared. I times I is I squared.
That's 6, right?
Yep. And then you got to remember important things about I squared. I squared is just -1. And if you multiply a -6 with a -1, you just get a +6. So that I squared disappears and changes the -6 into a +6. Well, that's nice. 12 plus 6 then becomes 18. And -9i plus 8i is -i. By the way, I don't know if I ever showed you this or not. I think I did. Did I ever show you this? You can do i's on your calculator. 3 plus 2i. And then 4 minus 3i is 18 minus I. Look at that. It's right above the decimal button. If you hit second and then decimal. Well, that's kind of nifty. Anywho, here's what we're going to be doing on your assignment. Something that looks like this. These are called binomial radical expressions. Binomial means there's two terms.
Radical just means there's a square root sign in there or some kind of a root. We're just multiplying two binomial radical expressions. It is no different whatsoever than any of those two review problems that we just did.
It's the same exact method. You distribute. We're going to work a couple of these together, then you're going to try a couple on your own. Same exact process. The FOIL method, if you want to call it that. So here we go. 3 times 2 is 6. Now you got to be careful here. 3 times negative square root of 5. Can the 3 combine with the 5 to make 15? No. One's on the outside and one's on the inside. So they got to stay. The 3 stays on the outside, the 5 stays on the inside. So it's minus 3 square roots of 5. All right, now what? Yeah, those have to multiply together. The 2 root 5 times 2. What is 2 root 5 times 2? 4 square roots of 5. Alright, here it is. The last one. 2 square roots of 5 times negative square root of 5. So that's going to be minus 2 square roots of what? Remember, when you're multiplying, you also multiply the terms on the inside. When you're multiplying radicals, you multiply the terms on the inside. So 2 root 5 times the negative root 5 is negative 2 root 25. Yeah, square root of 25. The square root of 25 is just 5, and then negative 2 times 5. Negative 2 times 5 is negative 10. So that last term's changed into negative 10. So we have 6 minus 3 root 5 plus 4 root 5 minus 10. Anything combined? Negative 3 root 5 can add to 4 root 5 because it's the same index and the same radical. What about the 6 and the negative 10? That can combine into negative 4. 6 minus 10 is negative 4. And then negative 3 root 5 plus 4 root 5. So negative 3 plus a 4 root 5. So it's just 1. You don't even really need the 1 there. You can just leave it as root. So it's negative 4 plus the square root of 5. Okay, we'll do one more together, then I'll have you try a couple on your own. So let's try this one. 3 minus root 7 times 5 plus 2 root 7. Same type of thing, we're just distributing. So, 3 times 5. Let's speed this up. This is taking too long. 3 times 5. 15. 3 times 2 root 7 is 6 root 7. All right, so far so good. And then we have negative root 7 times 5. So that's negative 5 root 7, yeah. 3 times 5. No. Nope, that's 3. And then negative root 7 times 2 root 7 is negative 2 square roots of 49. But the square root of 49 is just 7. Negative 2 times 7 is minus 14. So what we have is 15 plus 6 root 7 minus 5 root 7 minus 14. 15 minus 14 is 1. And 6 root 7 minus 5 root 7. 1 plus root 7. Man, math is so easy. Okay. Here's one for you guys to try. Try to get as far as you can on your own. Do the problem 4 got it problem. Page 249. The problem 4 got it problem. You really have no idea on how well you understand a problem until you try it on your own. It looks easy when I'm doing it up here for you. Okay? But when you sit down and try to do one on your own, that's when you really find out, oh, I don't know how to do it. So don't just assume because it seems so simple that you can do these problems. Try it. Okay, if you're finished, turn to somebody that's around you that's also finished. Compare. Contrast.
Like 3 hours. Spoiler, 5. Wait, what are we doing? 4, 5? You said 4? Yeah, 4. 24. Yeah, 45 plus 16. No. Oh. It's this one.
Easy homework?
No, it's the problem. It's right here. That's right, the problem. Yeah. 45 plus 16. I keep adding them, I don't know why. I did the last problem too, I added those two in there. tired and can't do this.
All right, take it out. 46.
Adding those two numbers up from the last one, it's adding like
46 plus 16 root 5. Okay, 3 times, just real quick here, 3 times 2 is 6. 3 times 4 root 5 is 12 root 5. 2 root 5 times 2 is 4 root 5. And then 2 root 5 times 4 root 5 is 8 square roots of 25. But square root of 25 is just 5. 8 times 5 is 40. 40 plus 6 is 46. 12 root 5 plus 4 root 5 is 16 root 5. So it's 46 plus 16 root 5. Okay. Okay. Real quick.
This is review. This part. Come on, write it down. You should have heard this word before. Conjugates. We used it back in Unit 2. When we talked about complex zeros, they always come in conjugate pairs. That's what we learned.
So write this number down. 4 plus 2i, that's a complex number. Draw a little arrow like this. And then write the word conjugate. Every single complex number like this has a conjugate pair. It would be 4 minus. You remember this?
Yep.
4 plus 2i, 4 minus 2i, those are conjugate pairs.
Same for rational, like the rational.
Yep.
Now that, identifying the conjugate, that's easy. What we really had to do back in Unit 2 was multiply these two things together. So let's write this. 4 plus 2i multiplied by its conjugate pair, 4 minus 2i. All right, let's be real careful. Before we do this, though, does anybody remember what happens here? If you multiply a complex number with its conjugate, all of the i's disappear. Yeah, that's nice. Good memory. So, let's see if that still happened. Maybe math changed in the last 4 weeks, and that doesn't happen. I don't know. You never know. 4 times 4, 16. 4 times negative 2i is negative 8i. 2i times positive 4. Uh-oh. And then 2i times negative 2i is negative 4i squared. Well, it looks like math hasn't changed. Still the same old, same old. Negative 8i, positive 8i, those cancel out. Negative 4i squared. Remember, I squared is just negative 1. So all that does is change the sign of the number in front of it. So it's plus 4. 16 plus 4 is 20. Well, that's just super. Again, you could have done that on your calculator too with i's. 4 plus 2i times 4 minus 2i. Look at that, it's 20. Dang, we're so smart. So, these type of numbers, 3 plus 2 root 2, they also have conjugate pairs. Much like those complex numbers have conjugate pairs. So, write that down. 3 plus 2 root 2.
3 plus 2 root 2. think the conjugate is?
3 minus 2.
All right, so write that down. 3 minus 2 root 2. That's the conjugate. And much like with complex numbers, if you multiply these radical expressions with its conjugate, the radicals should disappear, and all you should be left with is a number. So let's try it. 3 plus 2 root 2 multiplied by 3 minus 2 root 2. If you multiply this correctly,
All of the terms that have a radical should cancel out, and all you should be left with is a number.
so 3 times 3 is 9. 3 times negative 2 root 2 is negative 6 root 2. 2 root 2 times 3 is plus 6 root 2. Those would cancel out. All right, be careful in this last one. 2 root 2 times negative 2 root 2. It's negative 4 times the square root of 4.
That's negative 8. And yeah,
But the square root of 4 is just 2. Negative 4 times 2 is negative 8. The two middle terms cancel out. 9 minus 8 is 1. That whole mess of a problem just multiplied down to 1. Cool, huh?
Yeah.
It is, I know. You don't have to tell me, I know. Math is cool. All right, y'all. That's it. We're done. Well, hold on. We're done with today. Remember, though, this lesson isn't over. We still have a little bit of 4.3. Let's save it till next.